Hey, how's it going, guys? It is me here for BE1500, my group project, my data set for the for PUBG. This is basically a data set in which you take PUBG statistics, talking about killer placements, killer positions. In the brief overview of the game is PUBG is a battle royale game in which 100 players are dropped down into a map and you basically fight for the number one spot. You have lots of elements, game elements, which kill you. There is a zone that you have to be in throughout the map. It's very similar to Fortnite, if you've heard of that. So let's get right into the code. First, before I start that, actually, I wanted to talk about why we chose this code, why this data set actually means something to someone. We chose this code because everyone in our group knew about PUBG or have played PUBG, or have played Fortnite or another battle royale in a similar type of game, and how this helps people understand what type of data this is, how to make sense of any of this data. It's useful in the sense of what weapons are very good at the game. You could basically tell like pistols and stuff like that aren't that great, but AKs and stuff like that are a lot better. Assault rifles, you can tell sort of by common sense, but this data will tell you for sure that these weapons towards later game are a lot better. Early game, your pistols and stuff like that, but that's not what the statistics are telling you. It'll tell you around where mainly the final kill positions are. Usually it's random, but using a lot of this data, you could sort of tell where basically throughout the map that final kill will be around. A lot of times it's very random, but most of the time it's a thought out position on the map. And then I'll tell you placements of certain players. So these aren't all the players in the entire world or up until this day. This is basically one set of data points during alpha that we used, because that would be probably over 600 million data points. So we shortened it down a lot to get this data set. So let's get right into the code. So basically we open up using a menu. This is basically use a switch case. So if you click on any of these, it'll run a certain data point basically. So we'll start off with the average placement per weapon. So you go into the menu, you click on a weapon, and then you get a weapon types. So say we want a assault rifle, and then we choose a Scar L. The average placement of players in this game is 11.6. That means using a for loop, it used a counter basically, in which it went through all the data for the Scar 11 and the ranks of those, and it basically just gave an average of where the player, when they were holding that weapon, where they placed, or if they held that weapon during their final kill or anything like that. You could also place between all these assault rifles. You could give a placement in which where the assault rifle ranks at. This one takes a little bit longer to load. Basically, you could tell that the Scar 11 is it places a lot less. That means you have a higher chance of winning with the Scar 11 against the AKM, which is also a higher recoiled weapon in the game. The Gorza, which is a very well assault rifle back in the alpha, you place a lot closer to first if you are using it, just because it's a more powerful rifle. If you go back to the previous menu, you can also do a graph of all the weapons, basically taking all 22 weapons in the game and giving a placement of that. So this goes through all the data sets, takes all the ranks, categorizes them using logical indexing, and then with that it will spit out an average of where each of these weapons are. So we couldn't fit all the names of the data, all the names of the weapons on here. So what we did is we numbered them, and you could tell by the pistols are 0 through 5. The machine guns, which are your LMGs, your heavy machine, very weight heavy weapons. They do place a lot higher still because you can't run with them. Your backpack's either too full or anything like that. Your shotguns are very good for close combat, and then the assault rifles and snipers do place a lot lower because the sniper rifles and shotguns actually kind of dominate the game. The Remington and stuff like that. So if we get out of this graph and we go into the polyfit graph, it basically takes the weapons and shows a graph in which what weapons are, draws a line, basically a linear line in which it shows where the weapons sort of decrease in rank, and that'll give you which weapons rank the best. There are a lot of outliers on this. So according to the shotgun, there are a lot of shotguns that do place first because close quarters combat, but the AKs and stuff like that do end up placing as a better weapon. So with that, we have our next data set, which will give you who is the best PUBG player. So if you click on that, it will ask you to put a player's name. We do have one, and we're going to use Crazy Portuguese. His is going to come around 0. Yep, and it'll tell you that this player is God tier and give them a medal. So what we did with this one is it's also a for loop that gives a counter, takes all that times that person has came up in that data set and divides it by how many times that counter is ran through. Then it will split you up the data as a result of one, it will give you their rank, and then it will categorize them by where they place. If they place in the top 10, it'll basically display players, the top 10 player, and give this person a medal. He is a God tier person. If you're around 90 to 100 in average, I tell you to remove this game and go install Uno because that'll probably be a better option for you. So then we also have, I basically took that data set and flipped it around. It's using literally the exact same code, just the display is opposite. So if you type in who is the worst PUBG player, and then we choose Dexter 2003, he is ranked 10, which means he is actually closer to top. Someone get this person a medal, which means that he is a very well player. If it's ranked even closer to 0, then you are a very good player. It's just basically the same victim placement, just flipped on the other way. So it shows you where the player placed victim wise. So if they place closer to 0, they're a good player. Most common kills, location of each gun. So this spits out XY coordinates. Where if you click on any of these weapons, so let's say S1897, which is a shotgun. It will tell you that the common position of this in XY coordinates is that coordinate right there. And this coordinate, if you put it on the map using the coordinates that is given in game, it'll tell you this is in a towny area. Shotguns do dominate in that area. Click on another one, Car 98, which is a sniper rifle. Common kill location is for the Car 98, it does not come up actually. That one. The Car 98 was super spread out, so it would not give a data for that one. The most common kill location for the AWM was basically, this is a hilly region on most of the maps. A lot of the map layouts are very similar, so you can use the same data points on the maps basically. So it is common kill location. This is a hilly area in the map, very secluded. It's not in a town area, so you're able to snipe from a distance. So let's go back to the menu, and then we'll go back to the main script. So these are all the graphs of time versus placement and position. So if you click on this, it'll give you a time versus XY position. So throughout the day, where are the placements of certain people? So you have 24 hours in a day, and it'll tell you where around in the portion of the map that final kill is usually held at. It's usually held in a towny area. That's usually where the circle ends up because you start coming in from both sides or all sides, and so you are then having a very large population of people dying in very towny areas. Most people do drop down early game in a very towny area because they think that there's more stuff, but you could also do the same thing in distant regions too. Here's a time versus placement. Basically, it'll take the 100 players, and over time, where do most of these average players place? A lot of people do die early game throughout the day. Usually, most people do die within like the first 15 seconds or 5 minutes of dropping either, just because you got to find weapons. You have to be able to be smart throughout the game. So they place, if you're not smart enough, you won't last throughout the game. So let's go back to the main script. Finally, we have a guessing game. This guessing game basically takes all the weapons and what is the average of each of the weapon. It takes a little bit for this one to load because it has to basically load all the data for all the weapons and then divide them by 22, and it'll give you an average for the certain weapon. There we go. What is the average placement of all guns? So the actual answer is 17, where all the weapons placed. And this data kind of really doesn't tell you anything, but it just a cool game where it just says, oh, if I put all these weapon datas and where everyone's placed, are the average weapons placed around all the weapons placed around 17th. Kind of doesn't tell you anything. It's just kind of a cool game. So you could just end the program here and I'll close it out, and then it'll tell you thank you for using the program. One thing I wanted to discuss was how the project helped me understand MATLAB. There's a lot of portions in MATLAB that I didn't get through class, through lectures, through videos. So I learned them through just working with my team, basically it's basically working with other engineers in a sense where we're always working as a team. So their ideas helped. Like I thought that logical indexing would be good for mine, but then I was like, my teammate Brady was like, use a counter and then divide everything using the counter, and I was like, oh, that's a lot smarter and that's a lot more efficient, because if you ran that code using logical indexing, it would probably take 45 minutes to run instead of like 30 seconds. The other things that I did learn is I could use this in my field, in which 3D graphing, 3D plotting and stuff like that would be a lot useful. Basically take for civil engineering, you could take a building and put it into 3D placements and find tension points and stuff like that. So it does give me a better understanding of how to use MATLAB. I learned a lot of different things using what else? Like how to index things, how to write code more efficiently. Like my code usually was very all over the place. Like you do have a structured code, but I kind of just like jumbled and put code together. I didn't really space it out. Comments helped and everything like that, and the peer reviews did help throughout the project. So that's all for this project. That's everything we've learned using for loops, while loops, counter, case structures, and everything like that. So that's where I'm just gonna end up. Thank you for using this program. Thank you for checking out the video.